In this video, we will examine how the ACR Systems PowerWatch, using the Event Reader software, reports the event's information to help you better understand and analyze the data collected. After the PowerWatch VDR has captured some event data, you can download it and view it for analysis. Start the Event Reader software and connect the PowerWatch to your computer via the LIC Lightlink cable. Select the COM port the LIC cable is installed to, and then click the Download button or the Events tab. The data will begin downloading. When complete, the data will be displayed in a tabular format. Each event captured will be reported with an event number, the start time, the description of the event, the extreme value or reading, and the end time or duration of the event. An end time for a long duration event will be reported in hours, minutes, and seconds. Events that are shorter than 1 second will be reported as number of cycles. An event that is less than 1 cycle long will be reported as a degree or position on the sine wave. The PowerWatch can read impulses or spikes as short as 1 microsecond in duration. Impulses usually occur in clumps or groupings that oscillate between positive and negative values, diminishing in magnitude quite quickly. They can be quite large in magnitude. Hundreds of volts is not uncommon. An important point to note about a multiple impulse event is that the voltage readings in the extreme column will be the total voltage of any impulses that occur more than 100 microseconds apart. When multiple impulses of different polarity occur, their absolute values are added together. The degree in the fourth column will be the position or angle in the cycle of the first impulse. The angle of a neutral to ground impulse is referenced to the start of the hot to neutral sine wave. A sag of less than 70 volts on hot to neutral for greater than 1 second will be reported as an outage. The unit will report an outage of 8 seconds as it goes into power fail mode and will check the line every 8 seconds until it detects the power has been restored. The resolution of the timestamps in PowerWatch and the Event Reader software is 8 seconds. The timestamp reported in the software is in 1 minute resolution. The PowerWatch takes its clocking from the precise 0 volt crossing of the sine wave every half cycle. Loss of synchronization occurs if the PowerWatch gets out of step with the 0 volt crossing of the sine wave. This can occur if there is a lot of electrical noise on the line, causing the voltage to bounce back and forth across 0 volts in a non-repetitive way. Usually there will be several impulse events or clusters reported accompanying the loss of sync message. Excessive harmonics or noise on a power line may cause severely distorted voltage waveforms. While not common, these distorted waveforms could result in extra zero crossings on the AC line. PowerWatch synchronizes itself to the consecutive positive and negative zero crossings of the AC line every 8.3 milliseconds at 60 Hz. Should the voltage waveform be so highly distorted that unexpected zero crossings are detected, PowerWatch will report a loss of synchronization relative to the measured voltage waveform. This loss of synchronization will be recorded as an event unless the measured voltage falls below 70 volts for the 120 volt North American model or below 140 volts for the 220 volt models, in which case the event will be recorded as an outage with a start time equal to the original loss of synchronization event. Open events, that is events that are in progress, at the time of download, are displayed as open with a number of 0. You can open a previously saved file by clicking File from the menu bar at the top of the screen and clicking Open. Click on the file you wish to open. Clicking the Quick Summary button will display a summary graph of all events collected. There are several options for fine-tuning the graph, such as chart type and timescale. Clicking the Event Distribution button plots the recorded events within the CBEMA ITI curve. The CBEMA curve is a precursor to the ITI curve and was published in the 1970s. The curve is published by the Information Technology Industry Council, formerly known as the Computer Business and Equipment Manufacturers Association. The intent was to produce a curve that can better reflect the performance of typical single-phase, 120 volt, 60 Hz computers and their peripherals, and other information technology equipment such as fax machines, copiers, point-of-sale terminals, and is generally applicable to other equipment containing solid-state devices aside from being specifically applicable to computer-type equipment. This curve indicates an AC voltage boundary that most equipment can tolerate without experiencing unexpected shutdowns or malfunction. The curve is primarily intended for 120-volt 60 Hz systems. Other voltages are not specifically part of this representation, and it is the responsibility of the user to verify that the curve is applied correctly at other voltages. There are numerous published articles and information about the curve available online for further reference. As with all matters pertaining to any electrical power installation, consult with your authorized local electrical codes and certified professionals for more information and guidance. All ACR product comes with free technical support for the life of the product. Please visit acrdatasolutions.com for more information and videos. And don't forget to like and subscribe to our YouTube channel. Thanks for visiting ACR Systems.